Welcome to hear about sustainable IT and API performance, and especially how do they belong together. My name is Merja Kajava. I'm with Aavista, and I'm going to discuss the performance, especially from the API point of view. I have a long experience with the performance from different angles, as architect, as performance analyst, as performance tester. So I have seen the good and the bad what comes with the system and API performance. And I believe this is now a very kind of important, even acute topic right now in the current time with regards to sustainable IT. We have seen quite interesting headlines regarding the AI for the past year and two with the emergence of the ChatGPT and the Gen AI. And this has brought very new opportunities for using and applying the AI for everyone, I would say, who is dealing with the IT. But there are also some kind of side effects, and this is now seen in the use of power demand. And there are some headlines now. Now, for example, the AI is poised to drive 160% increase in data center power demand, according to Goldman Sachs. And this means that, for example, in the United States, America is running out of power, according to Washington Post news in March 2024. And this is actually seen in the numbers in the electricity consumption. The numbers were actually going down on 2020 when COVID started, slightly increasing 21 and going slightly down 22. But year 2023, there was more than double use in the electricity usage. And this is now in the North America. And this one is quite opposite what is really kind of the tendency, because we need to go down on the energy consumption. Because not everywhere the energy is provided with the green means. So this one is slightly concerning number. A similar thing is happening also in the European Union, and the numbers are now expected to increase for especially the data center usage, increase due to the AI and the cryptocurrency by double by 2026. So these are again numbers which should be going down, not up. And why is this something which is happening? We can't do anything about it. There are ways to kind of take into account, and that's where the API performance is one factor, where it's possible to take actions to be wise about how do you use the APIs and how do you provide the APIs. Here is still one more comparison between normal Google search and ChatGPT request. These are now estimations from 2023 with regards to energy consumption. And if you compare Google search, it's a text-based search, and normal APIs are still a bit faster, less consuming energy. So this one is something to think about as well, a 10-fold time difference in the energy consumption when you are using Gen AI. So this is also a kind of example of the case when even the same type of functionality can be performed in a different way depending on the underlying technology and the architecture. Here I have comparison of performance by close to 800 API providers who have implemented the same API specification. This API specification is fetching a small REST API response, and you can see that there are a big difference in the performance, in the response time. The mean is 0.25 seconds. The minimum, the fastest is 0.05 seconds, and slowest in this sample 1.4 seconds. So a bit similar 10-fold difference as we saw with the Google search and Gen AI. Here the requests are sent from Ireland, and as you can see from the map, the actual API providers are located across the world, and here the latency is also adding to the performance. But if you look at the kind of these distant API providers, you can see, for example, in the New Zealand, the latency is not that big, so you can get less than 0.4 seconds response time even from very distant location. So, for example, for the New Zealand, you can see that the API backend is implemented in different ways, producing different type of performance. So what is the API performance? What are the elements? There are kind of two main things. You have the performance, which is especially seen by the API consumer, and the scalability. That's how can you actually provide concurrent usage for the same API by multiple API consumers. And once you start breaking down, you have the response time, throughput, memory usage. Those are more like the backend efficiency metrics. The API performance is typically considered from the API provider point of view, but there are actually two parties involved because the API consumer also has very important role. So you always need to consider both parties, the consumer and the provider. And here the main kind of elements are the payload size, how big requests and responses are handled when you are invoking the API call, and at what frequency are you sending those requests. If the API is well designed, you can kind of have small granular API responses with paging capabilities. If the API consumer is pushing the requests every second, that is not going to be a very good performance, because it might kind of affect the API provider itself with the scalability. And the other way around, even if the API consumer is sending only on a need basis requests, if the API provider is providing only huge, massive APIs, the API consumer cannot do too much. So it's the combination of the two parties which is important to achieve a good performance. So the API consumer actually, when starting to integrate a new API, it's important to consider that how many requests are done, how often you send the requests. Is there any caching available? Do you always need to fetch the data, or can you keep some local cache if the data doesn't refresh that often? And also, can you do any paging? For example, if you need to deal with 100,000 items, do you really want to show those items on your end user mobile phone, or can you actually do paging? Just fetch the 5 first items, and then gradually, as the end user is scrolling, you will fetch the next ones. So API consumer has a big effect on the performance. Another important element is the network, especially if you have the end user who is using the service or application from the mobile phone, because here you actually start to get the network effect. There will be maybe several base stations, you might use them. The end user might have Wi-Fi, and it goes to the API consumer's own backend, possibly, where the request is forwarded to the API provider and the response is sent back. So there are already, even with this very simple scenario, quite many kind of points. So here the network capacity of course affects the performance and the latency, but here the size of the requests and the payload is starting to affect. And if you think about the round trip, there will be many networks between the simple mobile app and the actual API provider. So here again, the frequency and the payload size are very important. And now we are getting to the API provider. So the API provider is the important factor for the API performance. And here kind of the structure, the technological choices, the architecture, and the actual API design is important. And also that how many API requests are sent within the private APIs, or maybe there are some third-party APIs. So the similar question about the caching, the paging is also important. And here also, when we think about the energy consumption, if you are using a lot of third-party APIs, within your own API implementation, you need to consider these same things as the API consumer discussed a bit earlier needs to do. And putting all this together, even any individual request is not, it's just one request and it can be handled, but once you start to get hundreds, thousands, tens of thousands API consumers, concurrent consumers with the spike times, with different frequencies of the requests, that's when the scalability really comes to the question. And this one is also again the deal between the API consumer and provider. So typically rate limits are applied by the API provider to avoid these too frequent calls by the API consumer. So these are kind of the main elements of the API performance. And when considering the API backend efficiency, this one is actually built from the design. So the architecture has big importance, especially the API design, how granular or large the actual API footprint is. That one is part of the design of the API. The technology choices are very important, and similarly, how do you invoke other APIs? These are things what you can't really kind of fix afterwards if you are in the situation that you are getting close to the production and now the performance is not so great. You might have to do bigger refactoring if these things have not been considered from the get-go. So when starting to enroll a new service with API, or also when consuming a new API or integrating towards a new API provider, you actually need to specify the performance requirements. First, what is the expected performance in the normal usage and with the peak usage? Typically, it's quite difficult to get any numbers. For example, the expected response time. So it's good practice is just to put some reasonable numbers, and that will maybe open the question, kind of the discussion with the business owners and other stakeholders. The performance testing is really, really important, and the monitoring of the performance, and not only during the performance testing, but also once the API or the integration is into production. And it might mean that some adjustments need to be done depending on the usage, especially if there will be more API consumers or different type of behavior from the API consumers. So how do you actually deal with the carbon footprint for the APIs, considering that you have now designed an API and it's behaving well? How can you actually see what's the carbon footprint? There are carbon footprint calculators. If you use any of the big cloud providers, they already have calculators included in the cloud billing. And the billing is very important thing also in relation with the API performance, because well-performing API is typically much cheaper, especially if you run on the cloud. AWS has, here is an example of the AWS footprint tool, and similarly the carbon footprint from Google Cloud. And you can also see the scopes, and especially with the scope 3 is important. That's part of the ESG kind of calculations. Typically, you need to deal with the scope 3 emissions when using a cloud service. There are also open source calculators which you can hook to the cloud environments, for example, cloud carbon footprints. And this is very interesting tool if you are working with multiple clouds at the same time. So you can get the summary and maybe even do some comparison between the cloud providers. So as a conclusion, it is possible to build a sustainable API solution. It needs a well-performing API, well-designed API with also tracking of the carbon footprints. And it's not enough for the API backend to be well behaving. There is also a need for responsible use of the API on the API consumer side. So these are the elements of the sustainable API solution. And this is getting much more important, also even when considering that looking at the numbers we started, right now the energy consumption is going up, and we should actually squeeze the consumption down. So that's why it is so important to consider the performance of the API.